Welcome back. This is Mr. Hassan's Maths channel, and I am answering a question from one of the Solomon papers. This is from Solomon E, and it's also from my end of topic worksheet for P3, question 8 from my the first differentiation worksheet I have. And this question here is to do with exponentials and logarithms, and it says here, figure 1 shows a graph of the temperature of a room T Celsius at time T minutes. The temperature is controlled by a thermostat such that when the temperature falls to 12 degrees Celsius, a heater is turned on until the temperature reaches 18 degrees. The room then cools until the temperature again falls to 12 degrees, and then of course it heats up and then cools and so on. Okay, for T in the interval between 10 and 60, okay, for a small t, the time in the interval, here you have two different t's. You have the small t, which is the time, and the big T, which is the temperature, right? So it says for the time in the interval between 10 and 60 minutes, okay, the temperature is given by T as the temperature equals 5 plus AE to the power of minus K times the time in minutes, where A and K are constants. It says given that T equals 18 when the temperature is 18 when the time is 10, and the temperature is 12 when the time is 60, show that K equals 0.0124 to 3 significant figures and find the value of A. Okay, so now, basically what we can do here is we can substitute these pairs of values into this equation. So they've told us that when the temperature is 18, the time is 10. So when T equals 10 minutes, the temperature is equal to 18 degrees Celsius. So if we substitute that into this equation, you have 18 equals 5 plus A e to the power of minus K times T. And here the time is 10. So that will be 10K minus 10K. All right, instead of T, we're going to have 10. So that is one equation, which we can actually simplify a bit by we can subtract 5 from both sides. So we have 13 equals A e to the power of minus 10K. So that's one equation here, we can say. And the second equation, when the time equals 60 minutes, the temperature is equal to 12 degrees Celsius. So from this, we can set up another equation. We can say that 12 equals 5 plus A times e to the power of minus 60 times K, which gives us 12 minus 5, which is 7, equals A e to the power of negative 60 times K. And we call that equation 2. Now, if we want to solve this equation, we have two equations and two unknowns. Now, one of the easiest ways to solve an equation like this is, for example, if I took equation 1 and divided equation 2, that will eliminate the A's. So I'll have 13 over 7 equals, and I have e to the power of minus 10K divided by e to the power of minus 60K. Okay, if you divide them, the A's cancel out. So then I can use the law of logarithms, or so law of indices. I can say this is like e to the power of minus 10K minus 60K, because we have the same base and we're dividing them, so we can subtract the indices. All right, so this is going to give minus 10K plus 60K, which is going to be positive 50K. So we can say from here that 13 over 7 is equal to e to the power of positive 50K. Okay, and now we can say, let's take the ln of both sides. So if we take the ln of both sides, we end up with ln of 13 over 7 equals 50K, because we're taking the log to the base of the term to which we want to, or the thing that we need to find, it's in the power of that thing, right? So if 50K is in the power of e, we take log to the base e, which is ln. So we take log to the base e of this side, use a power law, you get 50K equals ln e, 50K times ln e, sorry. So ln e becomes 1, so you're left with 50K, and you take log to the base e on this side, that's ln 13 over 7. So now we can say K, therefore, is equal to 1 over 50 times ln of 13 over 7. So that should give us our answer. Let's hope that's correct. So we have 1 over 50 times the ln of 13 over 7. And that gives us 0.0 0.012380 0.012380 continues on. So we want to write it to three significant figures. So the first significant figure starts here, 1, 2, 3. So it's going to stop there. So you have 0.0124, and that's exactly what we had to show. So that was required for k, to find k. All right, and then it says and find the value of a. Now it's very important. I should have actually highlighted in the beginning. Some people, they don't read the question fully, and they might miss this second part here, and find the value of a. Sometimes it says part 1, find k, or show that k is equal to part 2, find a. It's kind of clear in the question that there's two parts to it. Here, sometimes you might just stop at this part, find k, and forget about the rest of the question. So be very careful. In fact, at the beginning of the question, to take note, I have to find two things here, because when you finish the work for k, sometimes it might not stay in your mind that actually you've got to find a as well. All right, so take note of that at the beginning of the question. It's always better. Make a note of something that might be easily missed at the end. So now we've got to find the value of a, which is not too difficult now, because we have these two equations. We could use either of them, whichever one we want. So for example, if I use the second equation, I have a is going to be 7. If you divide both sides by e to the power of 60k, you'll have e to the power of negative 60k. You have 7 divided by e to the power of negative 60k, which is the same as 7 times e to the power of 60k. It's like the reciprocal. Instead of being underneath, it'll be on top, right? So I can just now replace the k with what we know it is. So it's 7 times e to the power of 60 times our answer for k, which was 1 over 50 times ln of 13 over 7. We can use the exact value. So therefore a is equal to, okay, so I've got this exact value, so I can just put this in my calculator. So I'll put 7 times e to the power of 60 times my last answer. Okay, and that gives me 14.7133, 14.7133, and I'll write that also to 3SF, which is a normal procedure, 14.7. So that's the value of the constant k and a. Okay, so there's k and a. So what I'll do is I will actually save this as a. Okay, so my a is 14.71 as it is in here. Okay, 14.71. And my k, what shall I save it as? I'll just save it as b, because there's a b in the question, so I'll save it as something. I'll save it as c. Okay, so my answer that I got before, which was this, I'll store it as c. Okay, so now, c is k and a is 14 points. Yeah, so that's what we've saved it as. All right, so now part B. It says find the rate at which the temperature of the room is decreasing when t equals 20. Okay, when t equals 20, when the time is 20. So we got to find the rate of the temperature decrease. Okay, the rate of the decrease of the temperature. Okay, so the rate means with respect to time. So what we got to find is how the temperature changes with respect to time. So we got to find dt, the capital T, the small t, right? The change of temperature with respect to time. So we've got to differentiate this expression, okay, and then substitute time equals 20 into the gradient function, basically. So when you differentiate 5, it becomes 0. When you differentiate e to the power of something, it stays as it is. So this will be a times e to the power of minus k t, but then you have to multiply by the differential of what's inside the function, which is this part here, which is inside the function. Using the chain rule, you must multiply always by the differential of what's inside the function. So the main function is differentiated by staying as it is, as e to the power of something stays as it is. But then you multiply by the differential of what's inside, so you multiply by minus k, because if you differentiate minus k times t, you get minus k. So we can say dt is equal to minus a times k e to the power of minus kt, and we want to find the time when t equals 20 minutes. So in this time we can say it's going to be minus a, which we worked out as 14.7, times k, which we worked out as 0.0124. Okay, 0.0124 e to the power of minus 0.0124 times 20. Okay, so we can use these values if you want to. I'm going to actually use the more precise values that I've stored in my calculator. So I have minus, I have minus, and if I recall A, that's A, times K, which is, I've stored as C, so that's my K. All right. Times e to the power of, that's minus, and again, that's my value of K. Okay, so that's going to be stored as C. Okay, C, yep. Okay, and then times 20. All right, and that should give us negative 0.1422, negative 0.1422, it goes on. So we can say, therefore, okay, the rate of decrease, now because the word says decrease on it, it says decrease. The question says find the rate of the temperature. It doesn't say rate of change, it says decrease. We don't have to put the negative sign. We can say the rate of decrease is 0.142, okay, and it's degrees Celsius per minute. Okay, so even though the mark scheme of this Solomon paper mentions a minus here, technically we should not write the minus here. Okay, and if you did, I'm sure they would be lenient on you, but it's technically wrong to write minus here because the question's asking you for the rate of decrease. Okay, so in the question itself is, the notion that it's going down. So for example, if I said to you the temperature went down from 5 degrees to 2 degrees, by how much did the temperature decrease? Say it went from 5 to 2 degrees, it's decreased by 3 degrees. You don't say it's decreased by negative 3 degrees, right? Because the word decrease means gone down. So the same thing here. So the rate of decrease is 0.142 degrees Celsius per minute. So that's the answer for part B. And now for part C, which is probably the most challenging part of the question here. So the temperature again reaches 18 degrees when T equals 70, because between 60 and 70 minutes, it's, the thermostat switches on the heater and it goes on again, and then it stops at 70, it switches off, and then the room cools again, right? It says the graph for T time between 70 and 120 minutes is a translation of the graph for 10 to 60 minutes. So this part of the graph is a translation of that part of the graph. It's just translated basically across like this. Okay, so that is just a translation of that graph. Okay, we can see that that's how that works, right? It says find the value of the constant B such that for time between 70 and 120, the temperature is 5 plus B times e to the power of minus KT. All right, so what we know is the original graph, this one here, is T equals 5 plus A, which we know the value of, times e to the power of minus K, which we know the value of again, times T. Right? So if we think about it, this is a translation of that graph. This is a translation of that graph. So it's translated 60 units to the right. So it's like F, you could say T, because that's like the variable here. And we're going to say minus 60, because remember, when it's inside the function, it does the opposite. So it's a horizontal translation, okay, of 60 units to the right, because it goes like, for example, this point 10 goes to the same point 70. 60 goes to 120. So it's 60 units to the right. So we can say that this part of the graph, therefore, is equal to 5 plus A times e to the power of minus K times T minus 60. Okay, so that's what this part of the graph will give us, right? So we want to express it in terms of e to the power of minus KT. Right, so what I'm going to do here is I'm going to use the laws of logarithms. So this is 5 plus A times e to the power of. Now, what I can do is I can write this as minus K times T, and this will be divided by e to the power of 60 times K. Okay, minus KT, and you're going to have In fact, let me do it like this. Let me expand it. It's better. Let me expand this. This would be a, you can say a times minus kt times, it's going to be plus 60k. So I've just expanded that bracket. Okay, so that's minus kt plus 60k. Okay, so you can say t is equal to 5 plus a times e to the power of 60k, okay, times e to the power of minus kt, right? So that's what this becomes if you just rearrange this, right? A to the power of 60k, okay, and you're going to have times minus kt, all right? I mean, let me write it like this first, just to make it very crystal clear that I'm just rewriting this as 60k minus kt, and then I'm using the laws of logarithms. If I have a to the power of m times n, I can write it as a to the power of m, okay, times, a to the power of m plus n in the power, the laws of indices. So I have a to the power of m plus n is the same as a to the power of m times a to the power of n. So this is the same as saying t equals 5 plus a to the power of a times e to the power of 60k multiplied by e to the power of minus kt. All right, I can split these up into two terms like I've done there. All right, this is like a sum, 60k plus minus kt. And so I can write it like this. I want to have this as negative because this is negative here. Now what I can do now is I can compare this to what we have. This is t equals 5 plus b times e to the power of minus kt, which means that the b and this must be equal. So therefore we can say therefore that b must be equal to a times e to the power of 60k. And now we know what a is. It's 14.7 times e to the power of 60 times, and we have 1 over 50 ln of 13 over 7, which is our k, which we have saved in our calculator. So therefore we can say b is equal to, so we can just use the values in the calculator. So we have 14.7, which we saved as our a, okay, times e to the power of, and then we have 60 times our value of k, which we stored as c, okay, and that should be minus, by the way, minus k, so there's a minus here, okay. No, actually it's not, it's this. There's no minus there. It's 60k. So I'm looking at the wrong thing. It's this one. So there's no minus there. It's just that. And that gives us an answer, 30.926. 30.926. So we can round it to 3SF. Does it say how to round it? No. No, I did that. Did it right? Yeah. So it's 30.9. And there's our answer for B. Okay. So B is just a constant. So there's the answer. So there's B. And I hope that was clear. All right, we just have to understand in this question that they've given us the answer basically in a way. They've shown, I mean, we even if they didn't tell us it's a translation, we should be able to see that it's a translation, but they've told us very clearly this is a translation for 10 to 60. So we can see that it's basically moved 60 units to the right, which as a translation is t minus 60. So we can say that this graph, in terms of what we have, A is a times e to the power minus k times t minus 60, and then when we kind of we have to put it in terms of find what b is, so we have to kind of split this up, so it's in terms of e to the power minus kt, and then whatever's multiplying that must be our b. Okay, so that's a bit of a challenging one, but it's not too difficult. So there's the answer to this question from the Solomon e-paper. Other questions from this Solomon e-paper can be found in the playlist that will appear in this region over here. Other questions from my end of topic worksheet, differentiation 1, can be found in the playlist that will appear over here. You can subscribe to any questions from differentiation in general of P3 can be found in this playlist over here, and you can subscribe to my channel by clicking on this link, and you'll see a card appearing on the top towards, I think, at the beginning or certain times in the video. That card, if you click it, will take you to a video which explains how to use my channel in an efficient manner. Thank you for watching and see you soon.